Hello, all of you. We are going to get started with today. So to get started, here's what we're going to do. We're going to first start with the warm-up question of the day. So what you're going to ask me is, "Hey, Mr. Who, what did you do over Thanksgiving?" And then I'm going to tell you what I did because this is definitely a true story, 100% true. I did not make this up at all. So over Thanksgiving, I had an apple pie and I had a pumpkin pie. And then as a true physics teacher, I decided to play the game, which pie hits the ground first with myself because I have no friends. So what I decided to do is I throw apple pie perfectly horizontally, let's say with a velocity of 10 meters per second. I throw it perfectly horizontally. And at the exact same time, I drop the pumpkin pie vertically to the ground. So I throw one horizontally and I drop the pumpkin pie vertically to the ground. And I want to know which pie do you think hit the ground first? And then respond with your favorite type of pie. Shout out to all of my banana pies because banana pie is really good. So we'll take a couple of minutes to go through this, and then we'll see what we have. Um, I've made some modifications to the stream today just because I thought it'd be fun. So let's see if we can get some participation. The funniest part about streams and Twitch streams is when the chat just goes absolutely crazy. I think that might be asking too much, but it would be really fun if it was just like really crazy. And we've got a couple ideas so far. That's okay. Things that maybe drop at the same time. We got Zach here to think at the same time because gravity affects them the same. Let's see if we can get any more ideas in here. Um, Maybe we can also get some ideas on what your favorite pie is. Um, I like banana pie. We had a lot of very interesting pies last period. So let's see if we can get some. Let's get some pies and let's get some answers in here. So this is what happened over Thanksgiving. 100% a true story. I never make up stuff at all. So what I did over Thanksgiving is I had an apple pie and then I had a pumpkin pie. And as a true physics teacher, I decided to play the game. Which pie hits the ground first with myself? I throw an apple pie horizontally with a velocity of 10 meters per second. And at the exact same time, I drop a pumpkin pie vertically to the ground. And I want to know which pie do you think hits the ground first? And then respond with your favorite type of pie. And a shout out to all of my banana pies because banana pie is really good. Anyone have at least a favorite type of pie? It's so quiet today. Today is so quiet. Don't worry, we'll get through this. We'll get through today. Um, all right. Okay, we'll get through today. Okay, so we will look at which pie hits the ground first in a second. But today we're going to start what I call two-dimensional projectile motion. Um, So we've already done a little bit of projectile motion earlier, believe it or not, but I'm doing more of a formal introduction today. So what is a projectile? So projectile is, ooh, I think it's going up here. Hold on, something went wrong here. And also the slides are also on Canvas as well. Uh, there we go. Okay. So let's talk a little bit about projectile motion. What is a projectile? So a projectile is an object that basically is moving in a curved path due to gravity. So what happens is when you throw an object up or something, it'll start curving downward because of gravity. I mean, in a sense, it's in free fall, even if it's not going perfectly vertically. And that's because the only form of acceleration it's undergoing is gravity. And that's what free fall is. Gravity just means that the only acceleration is due to gravity. So again, projectiles will undergo acceleration in the vertical direction due to gravity. Gravity doesn't affect it horizontally. And when we talk about projectiles, projectiles generally don't have any sort of horizontal acceleration. And what this means that the initial horizontal velocity generally won't change throughout the trajectory. The horizontal velocity will generally stay the same. I use the word generally just because there are weird cases where we might analyze ones with horizontal velocity or acceleration. But in general, it won't have any sort of horizontal acceleration, and generally only have vertical acceleration due to gravity. So this is very, very important, and this is something we've already looked at a little bit. So what's very important to recognize is that the horizontal and vertical components of motion are completely independent of each other. Meaning what happens vertically has no impact on horizontal motion, and vice versa. So this is why gravity only affects vertical motion and why the pies in the world hit the ground at the same time. What happens horizontally does not affect vertically, and what happens vertically does not impact any sort of horizontal motion. And this is why, again, the pies hit the ground at the same time, because even though one pie is thrown horizontally, that horizontal motion has no effect on its vertical motion. And both of them start with initial vertical velocity of 0, and they both accelerate due to gravity, which is the same for all objects. So when we tackle any sort of projectile motion problem, we want to break up the motion into two components, x and y. What happens in x stays in x, and this means any sort of horizontal positions, any sort of horizontal velocities, any sort of horizontal accelerations. And what happens in y stays in y. This includes any sort of vertical positions, any sort of vertical velocities, and any sort of acceleration, vertical accelerations. Both components may share the same times depending on the scenario, but again, I want to emphasize the word may because they can share the same times depending on how you set it up or depending on the scenario, but they may also have different times as well. So be careful with that. But X stays in X. You never mix X and Y together. It's like ammonium bleach. They are perfectly fine individually. They're great cleaners individually. You mix them together, everybody dies. So if you mix X and Y together, everybody dies. So I'd rather not have any deaths today during second period. You can die later on in life. But in second period, let's keep our X's and Y's different from each other. So we're going to revisit the ejection seat problem. Before we start complaining that I never teach you anything and that you don't know how to do a projectile motion problem, we already did one in Mario Kart Part 3. Mario Kart Part 3, question I believe 5D, when the car is moving horizontally and the ejection seat is launching you, and you have to figure out how far the car is from the ejection seat. That literally is a projectile motion problem. That's two-dimensional. So we've actually already done one before. So you're not allowed to complain that I don't teach you how to do anything because we already did one earlier. And I also want to give a shout out to the Mythbusters episode about ejection seats. RIP Grant Imahara, who died earlier this year. Grant Imahara was definitely an inspiration for all of us who like Mythbusters. But if you want, you can watch the Mythbusters episode. So how we're going to revisit the ejection seat? Well, we're going to change up things slightly. We're going to try to figure out some other things. So for this eject problem here, we're going to say that the car and the ejection seat are both initially stationary. They're both initially not moving. The car is actually completely irrelevant for this problem, so we're only looking at the ejection seat. The car is just irrelevant. Ignore the car. And then both of them are initially stationary. So in this problem here, we're going to try to figure out some initial velocities. So the ejection seat is launching you with a velocity of 40 meters per second at a 45-degree angle. What is your initial vertical velocity? That's one thing we're trying to figure out. What is your initial horizontal velocity? That's another thing we're going to try to figure out. And then what are your vertical and horizontal accelerations? So we want to try to figure that out as well. We'll take a few minutes to go through this. We have a motion that is diagonal, and so we want to decompose this into vertical and horizontal components. That's very important. This idea of decomposing, we have something that's in a diagonal at an angle, and we want to break it down to a horizontal and a vertical component. That's why we have an angle to work with. And then whenever you're ready, just put your answer in the Zoom chat. Anyone have any ideas? Angle in particular here is very important because the angle allows us to break down a diagonal into a vertical and a horizontal. If you think about it, you can make a right triangle out of this. Oh, sorry, I didn't realize that. I thought the chat was really quiet today. I didn't realize that it just wasn't updating for some reason. Apple hits first. Yes, they do hit the same time. Um, it's okay. Favorite pi is 3.14159. Geez, that is a deep. I wonder how many digits do you actually know? I know the first
I
what?
did 100 digits here.
Do you actually remember all of that? Or did you Google it?
I remember how to Google things.
Um, okay. I know the first 10 digits. I know however many are on the calculator. So it goes 3.14159, 2653, I think 539, something like that. 53.
I know that pi squared is equal to g.
Is that true?
It's actually pretty close. It's like 2 digits close.
That is pretty cool. So okay, let's see what else we have here. Apple pie. Apple pie is really good. I'm a huge fan of apple pie. For some reason, it's like for some reason like a lot of people feel like apple pie is like a pleb thing. To use the word pleb, but a lot of people are like apple pie is so plebeian. But I love apple pie. Apple pie is probably one of my low-key favorites. They do hit the ground the same time test. And apple hits first. I totally agree. Pumpkin pie is pretty good. I've learned to like pumpkin pie more, but pumpkin pie is pretty good. Pecan pie is also pretty good. Last year, we also had someone who said key lime pie. Key lime pie is also pretty good. As you can tell, I just love pie in general, so I'm a huge fan of pie. There's also cherry pie last period as well. What other pies are there? There's banana pie, blueberry pie, I think is also a thing. But yeah, pies are a huge fan. So in terms of our answers here, I think we're on the right track here. I will do it in a second once I figure this out here. Um, so yeah, so let's take a look at our not our pies, but this problem here. Voila! Wow, that is so cool. Okay. Wow, Mr. Gu, you're so tech savvy. I know. Um, so it took me. Okay. Okay. So yeah. So basically, like the key here is that we actually have a right triangle. There's a reason why this problem is kind of interesting. We actually have a right triangle. So this is the first. This is when you actually see that trig is kind of useful. We have 40 meters per second here. And then we have a 45-degree angle. So guess what? You can make a right triangle out of this. So basically, we want to figure out this thing, and we want to figure out this thing. So let's call this Vx. Let's call this Vy. So if we have a right triangle and we have an angle here, we can just figure out our Vx. So our Vx is just 40 times cosine 45. And then Vy is 40 cosine sine. Not sine 45. 40 cosine 45 is at 40 root 2 over 2, so that's 20 root 2 is 28.28. And then this is also 20 root 2 is 28 meter per second. So what is our initial horizontal and vertical acceleration? Well, the thing is, right, our vertical acceleration is going to be gravity. There's nothing else. So the key with identifying for acceleration, so here's the best way I think about when we identify acceleration in a problem. Is there anything pushing or pulling the object, right? It's one thing to be moving, right? It's another thing to be pushed or pulled, right? So in this particular problem, the ejection seat is being launched initially. After it's being launched, there's nothing pushing and pulling it other than gravity. So other than gravity, gravity is our only source of vertical acceleration, which is negative 9.81 meters per second squared. And then what about the horizontal acceleration? Well, there's nothing or pushing it, pulling or pushing it in the horizontal direction. So our horizontal acceleration is going to be 0. So as it hits, this is what your accelerations will look like in a lot of problems. Not necessarily all of them. I just want to be careful. Not necessarily all of them, but in any particular problem where you can't really think of anything being pushed or pulled, this is what it would look like. The exception to this, if I said, hey, the ejection seat, it has rocket boosters that are activating the whole time, then your accelerations might be a little bit different. But in this problem, all that happens, you get launched, and afterwards you just fall normally. So your accelerations are going to look like this. And then for velocities here, I just decomposed this diagonal into horizontal and vertical components using trigonometry. Hopefully this is all something that you feel comfortable with. Does anyone have any questions about what I did here? Anyone have any questions? This is all doable. Okay. Okay, so here is what we are going to do today. So on Canvas, there is an assignment called, what we're gonna do is we're gonna start a new assignment, a new project, if you will, I guess. Okay, we're gonna start a new assignment called World War II projectile motion. Yeah. So I actually love reading history because I'm kind of I do like reading history. History is very fun. Um, which may be a controversial opinion. I do like reading about history. And so one thing that I am way too into is just reading a lot about particular events in the past, which is what history is. So there's an assignment on Canvas called World War II projectile motion. I'll put a link in the chat so you can all see it as well. You can all see it. So what I'm gonna do is I'm gonna do a quick little intro to what this is about. So in World War II, so previously before World War I, most casualties, so casualties are people who are injured or killed in war. Most casualties are actually due to disease. So things like smallpox vaccines were not quite prevalent back in the day. So most people actually died a lot of disease. So there's a lot of like really nasty stuff. Things were not very hygienic back in the day. World War I was the first time where we start seeing modern medicine, vaccines, and that at least reducing the amount of disease. Then we also have the introduction of antibiotics, so penicillin, which were all also very helpful in reducing the amount of disease. And so because of this, disease took a step back. And also the weapons became much more modern, much more advanced, and much more deadly. And so because of this, people were dying a lot. World War I, there's a lot of casualties, and then World War II, there were even more casualties. So it was actually ridiculous. One of the reasons why there were so much casualties was because artillery became very, very, very powerful. Artillery, if you don't know, it's basically like imagine if a cannon was on steroids, because instead of just being able to shoot horizontally, like in like a little, if you watch Pirates of the Caribbean, right, you see these little cannons that are shooting like horizontally, and they fire this nice circular cannonball. Yeah, so modern artillery, you actually shoot upwards, and you shoot very, very, very far. The vast majority of the casualties in World War II were caused by artillery. 65% of casualties in the European theater were due to artillery, and then in the Pacific theater, 47% of casualties were due to artillery. That's a huge amount. And what makes it so deadly was that it has the accuracy and the firepower and the range of modern artillery just made it so that if you were a soldier or a civilian, you could die without ever having seen the opposing forces. So one day you're just sitting there eating, and the next day you get hit by an artillery shell from like 10 miles away or something, and then something bad happens. So that's what made it so deadly. One of the most important roles of artillery in modern war is through something called defensive support. So basically what happens is there's a front unit of soldiers who are under attack, and they would call for defensive support from an artillery battery. So basically saying we need artillery fire here, 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 and we need it ASAP. So what happens is once the artillery battery, they receive instructions, they will calculate the range, the altitude, and the trajectory at which to fire the batteries, and then they would have to keep calibrating it until it actually was hitting the target. So our goal for this assignment here is to basically create equations that will allow us to provide supporting fire, so for soldiers under attack, So I will provide you with different variables, and your goal is to basically figure out at what angle you need to fire the battery at. And then when you tell me an angle, so what'll happen is I'll give you a scenario, I'll give you some variables, and then you'll tell me an angle, and then I will tell you whether or not you hit, or I will tell you whether or not you miss. I might say something like, you missed long, or you missed short, which means that you shot too far, you shot too close. Now, and then once you do that, if you miss the target, you're going to make some adjustments to try to to your formula until you're ready for another attempt. And not necessarily the numerical answer isn't quite as important. I'm more looking in terms of, can you set up set up the formula for this that allows you to find the trajectory at which you want to fire something. Meanwhile, you're also going to record how long it takes to figure out an accurate angle. So basically, from the moment where you're ready to fire, you're going to start recording how long it takes. And this is just to measure your response time. Basically, in other words, how long it takes from, if someone were to say, hey, we need artillery fire here, we need supporting fire here. We're just trying to measure how long it takes to provide that accurate fire to our frontline unit. This is not graded. This is just for fun because in World War II, the Americans could get it down to 30 seconds. And this is without any calculators or phones or Google Sheets or whatever. So if someone said, hey, we need artillery fire here, they could calculate the trajectory, adjust for wind, adjust for altitude, adjust for humidity within 30 seconds without calculators or phones or Google Sheets, et cetera, which is absolutely absurd. So I'm just curious to see what we can get in our class here to see if we can match that in our class. But again, it's not graded. If you need to take more time, you should definitely take more time here. It's better to be accurate than it is to not be accurate. So for part one here, we're going to initially prepare to fire, provide artillery fire for a unit at the same elevation for us. So in other words, you start at ground at 0 in terms of elevation, and they start at 0 in terms of elevation. So you're going to write an equation that calculates the angle you need to fire an artillery battery at in order to hit a target that is X meters away. So I will give you the X, but for now you don't know it. So you just keep X as X. And then I will also give you a velocity at which the artillery shell is fired, velocity, which will be given to you. But for now, you don't know it. So leave everything in terms of variables. You don't know anything numerically yet other than, and I would even leave gravity as G. Don't put gravity as 9.81 yet, leave it as G. And then ignore air resistance. So just pretend everything is perfect. No air resistance. So you're going to set up an equation basically that allows you to figure out the angle at which you need to fire a battery using X, assuming that you know X and assuming that you know V naught, and assuming you don't really know anything else. When your group is ready for equation, just let me know, and then I'll give you a target distance and artillery velocity. And then once your group is, once I finish giving you group instructions, you can have one group start a timer to measure response time. Then you're going to try to figure out an angle, and then when your group finishes, I'll confirm or miss, hit or miss, and then if you finish, then you can either pause or stop the timer depending on what happens. But that I don't think we'll get to that today, so I'm just going to skim through that. So your goal here is to just create an equation that allows you to find the angle at which you need to fire something. So I think instructions otherwise are pretty simple. I think you're basically just trying to figure out an equation. I will give you a couple of hints because I'm feeling particularly generous today. First off, it is not as straightforward as you would think. It's not something where it's like you just do it in one line and it's just magically you get something. You will have to do a little bit of thinking of understanding the phenomenon that's going on, understanding some concepts. So it's not going to be as straightforward as you think. On the other hand, it's also not algebraically complex. This is not one of those things where it's like I'm testing how well you know your algebra or how well you know your trig. I'm not asking you to know you don't need your cosine law or law of cosines. You may need that in the future, but for this, you don't need anything crazy. It's just basic trigonometry, very basic algebra. It's not going to be a complex derivation. If you're writing more than a paragraph of lines, that's probably too much. You don't need to go that far. It requires a little bit of thinking, but it's not super algebraically complex. And so our goal is to try to figure out an equation for this. Okay. Does anyone have any questions before I let you get started? Okay, so I'm gonna let you get started, get in your Discord groups and get started. If your group has any questions, you can send me a message to let me, Zach will help your group first. If you're private messaging me, make sure you private message, the one that says Dylan Who. Don't private message the account that says don't private message me. unless you want everybody to see it. So yeah, yeah. Other than that, we'll get started, and then yeah, Okay, so we have a minute left. I'm sorry, I don't think I was able to answer everyone's question. If you still have a question for me, you can say a little after class, and I can answer them for you. We will pick up where we left off on Friday, so it's not we still have plenty of time to work on this. Hopefully, you were able to make a little bit of progress. It's a little bit challenging, but I think it's doable. It's not too complex algebraically. But we will pick up where we left off on Friday. Um, Other than that, we don't have any homework. Other than if you haven't submitted anything or if you have any revisions, please continue to submit those. I have not graded anything the last few days, so but I will be grading throughout the week, and I'll be giving you feedback throughout the week. So keep working on that. Other than that, I think that should be it. So I will see you all on Friday. Yeah.
Thank you.
Thank you.
Thank you. Have a nice day.
Okay, guys.
Yeah.